Yeah, I've heard of Cambridge University. It's sort of like the Northeast London, it's like the LSE of the Northeast London area. Right? So anyway, thanks very much for having me here. I'm going to be talking to you about quantitative text analysis done a social science way. I know there are a lot of people here from industry or people who've graduated from an academic context and they're going out into what we sometimes call the real world, which I've heard of. How many of you are in academic environments? Oh, okay. So anyone doing social science, or are you more computer science, machine learning? Okay, so what I'm going to be talking about is how to use tools of, I don't call it artificial intelligence. I think it would be more accurate to call it perhaps artificial intelligence. I think artificial intelligence doesn't really apply to the sort of tools that I'm using, but first we called it statistics, then we called it machine learning, then we called it artificial intelligence, because that's where the money is. So what I'm going to be talking about today is how to use text mining in a social scientific way rather than just generating knowledge for monetary use or to develop interesting insights, but in a much more controlled way. The emphasis here is on the scientific part. So the idea behind this is that text is not, as in a classical sense, say in a literary sense, interesting for its own sake. We're not interested in text because of how we're going to interpret it or what story it tells, or in some postmodern literary sense, what the text means. We're interested in the text because it represents data that was deposited by the authors or the process that generated that text. It's behavioral data in the same way that your app on your phone would generate GPS data or your car would generate engineering data. We're going to use text in the same way, and we're going to treat it like that. It's not really controversial unless you get into certain academic fields where the text can be some sort of sacred thing in its own right. We're not treating it that way at all. The key behind this in the scientific part is some form of comparison. Science involves comparison, a control group, a placebo, something where you're making a statement of some tendency about the text relative to some other tendency or some other input or some other variable. And this involves, in the statistical sense, using the tools that we know from inferential statistics, which is the ability to make probabilistic statements about differences, about comparisons, about the influence of one input on certain outputs or an output, or some form of probabilistic statement that would allow us to distinguish some observed distribution from what we might have expected given some other assumption, usually the assumption that there's no pattern, or what we would call a null hypothesis. Although I'm actually not a frequentist at all myself. So I'm now going to shift into an application, because I thought about how to do this, and rather than show you a series of abstract examples from my work, I'm going to actually talk about this in a very specific context. And that is going to be a project that I've been working on for the last couple of years, last 2 years actually, where I was analyzing what happened on about Brexit, the debate that took place on Brexit through social media, and very specifically through the Twitter platform. Facebook has now locked down its API. It's much harder to, or impossible for public people to but to get the public pages from Facebook, their textual data in the form of comments and posts from the API the way it was possible a few months ago. Twitter, on the other hand, has not put on such restrictions, and they even doubled the amount of text a few months ago that you can get from a tweet. So a lot more social scientists are going to be analyzing Twitter than Facebook. This was an EU-funded project. We collected some 26 million tweets from January to July of 2016, and we captured these based on search terms that were a set of predefined hashtags, usernames, and a few plain text search terms. This is the capture pipeline that we set up. We had access to the full fire hose, although we didn't need that because the rate limit of 1% of the total tweets that you can get through the public API, I think at any given time, Twitter consisted of like a fraction of 1% talking about Brexit, some 25% talking about Justin Bieber, the rest was Donald Trump. So we didn't need anything close to the rate limit for that. And the capture terms that we kept fairly constant in order to capture the same set was very inclusive set. So we had a very good, what we call in information retrieval terms, precision in recall for what we returned. Or as I tell my students, we got a lot of tuna and almost no dolphins. And we didn't leave too much tuna in the sea. We had about 3.6 million different unique users in our data set. We captured, these users tweeted an average of 7.2 times. The median user actually only tweeted once, but that was because there is a very large number, obviously, with this distribution. There's a large number of very high volume tweeters. The maximum tweeter was a bot who tweeted 81.1 thousand times about Brexit. The first application I'm going to show you, and this is just going to walk you through some of the ways that we threw data science tools to get information in a social scientific way from what is essentially data that contains text. But it also, like most textual data, contains metadata, and the metadata here is information about the users and information about the dates of the tweets and even the locations of the tweets, although I'm not going to show you some of the geolocation data just for interest of time. So the first thing we were interested in doing was using some known information about very obvious pro-leave and pro-remain cases that was numbered in just a few hundred users, actually. We expanded that to up to about 1,000 users. These were power users, a very obviously pro-leave, like, better off in, or stay in EU, username. We used those users to classify a simple machine learning algorithm, and this is one of the classic, simplest, but also most robust machine learning algorithms, in this case a multinomial naive Bayes classifier. We tried support vector machines, we tried convolutional neural networks, we tried all sorts of other methods, and because of the structure of tweets, which doesn't have a very complex linguistic structure, and because most of the patterns are driven by frequencies of terms and hashtags, we actually got very good results with the naive Bayes, and we didn't have to make decisions about implementing various aspects of things like the kernel types in support vector machines. So we stuck with that. We combined the tweets by user. It's a very common thing. We took the known leave and remain, and then what we did was we got a probability, and we took the bottom 10% and the top, the bottom 20% and the top 20, it was basically the bottom 20 and the top 20 in terms of the probability, and classified those users as leave and remain, and everyone else in the middle we called neutral. And just to see what the different performance looked like, for our feature selection, we got the best performance by essentially using all of the features. And some texts will tell you that you can just convert features into a binary situation, use what's called a Bernoulli classifier. You actually throw away a lot of information when you do that. The proportions of actual tweets that we predicted looked fairly balanced. So the remain and the neutral, as the polls were telling you before the Brexit referendum actually occurred, was also fairly balanced. And there was about a third of the users that were predicted to be neutral. Right, so this is not an interesting exercise of the outcome, but this allowed us to add some metadata to the text so that we could then do our analyses to partition leave versus remain. For example, if we plot over time the smooth tendency from January to July of the patterns of tweets of these three sides, we can see the spikes that occurred, especially right around the referendum. There's a huge spike in the volume of tweets, and if this doesn't look so impressive, just look at the y-axis, which will tell you this is a logarithmic scale. So we're talking about massive multiplicative differences here, because this is a decimal log scale. We can use this to characterize some of the users of known predilections when it came to leave and remain, at least at the time. And you can do this for members of parliament, because about 80% of the members of the parliament at that time in the UK had Twitter accounts. classifying them, we see a sort of breakdown where labor looked predominantly Remain. The conservatives were divided, but they were also predominantly Remain according to our classifier. And then, of course, we would have fallen flat on our faces if the sole UKIP person had been classified as Remain, and it wasn't. You also see the Scottish parties were Remain, the Northern Irish parties were Remain, except for the DUP. I won't say any more about that. We also could classify a few well-known Twitter users. We took every Twitter account that was associated with the London School of Economics that started with LSE something, and we were also all fairly pro-Remain, including, there's my account, including Sarah Hobolt and Simon Hicks, two colleagues who are experts in European Union politics. But then there was a strange account called LSE Eckford. We're thinking, who is that? We didn't know that person at the LSE, so we looked this person up. This is the sort of thing where you catch something in your net that you weren't intending, happens in data science and big data analysis all the time. Well, we can drill down and we can see that this is actually a somewhat crazy person in the United States who, by the terms of the public Twitter terms of service, allows me to repost this. And she was calling for mass impeachment for the traitor Democrats. So that was just a mistake. We can classify, we can do the obligatory thing with textual data and produce a partitioned word cloud. Here we've got the terms that are predominantly associated with each side. These were just hashtags. We can select out the hashtags quite easily and show a plot where the size of the term is proportional to the relative frequency. This is quite easy to do. We can also, this is shifting to another type of analysis now. We're starting to get into some of the machine learning. This is an unsupervised method for performing a type of Bayesian network analysis, not based on the text, but based on the matrix of followership. We can take all the users, we can determine a followership matrix of which users follow which users, and we can actually perform a scaling that we can interpret as a type of ideology once we've restricted the domain, of course, to Brexit. And we can interpret this as sort of an affinity towards Remain versus Leave. If we plot a density plot of this, and this is Pablo Barbera, is a colleague of mine at the London School of Economics in my department that I'm very pleased to say I hired 2 years ago. This is based on a paper he wrote in 2015 where he explains this method, and showing the Remain score across the x-axis, we can see that there is this bimodal distribution, which is exactly what we would have expected in the data and given what we know externally about Brexit. And this is simply from the Twitter followership network that we got, doesn't even use the text. Sentiment analysis is a very well-known thing to do with text. So this is a very common thing. This is one of the most monetized aspects of text analysis because it has a direct, it's of direct interest for companies trying to monitor public reaction, customer reaction to their company's brand or their products. We did this using a very old school method. We had a dictionary of terms that were developed by psychologists. We looked up those terms and the patterns related to those terms in the data, and then we counted them and we converted those into an index. In this case, most of these will be either taking a frequency or the logarithm of the odds of a pair of categories that are mutually exclusive. They contain categories about emotion, about politics, about power, interestingly about the type of language, whether it's quantitative or tentative, and about sadness and about future versus past. To give you an example, and this is not Python but R, which is I'm going to show you at the very end, just a little tiny preview of the R package which I've developed that we did all of the analysis for this project in. If we take the list element for this dictionary object, and we look at the patterns. These are what are called glob patterns. It's like a simplified version of regular expressions. You can see that these are reward-oriented language. Who comes up with this list? Some psychologists, University of North Texas. They've been cited a lot, and if they've been cited a lot, then it's good enough for everyone, right? If it's printed in academia, it must be true. Reward language. What we see here is that the Leave side was using much more reward-oriented language than the Remain side. They were talking about the benefits of leaving. If we look at positive versus negative emotion, and this is, once again, this is the logarithm of positive mentions divided by negative mentions, the logarithm of that product, so it's the difference in the logarithms of those two quantities, which gives you a better distribution for looking at these sorts of scales built from proportions. We can see that the leave was more positive relative to negative than the remain side. The positive language was coming from the leave side. The remain side was trying to scare the bejesus out of everyone of what would happen if we actually left. And that included talking about more of the sad consequences of the potential outcome of the referendum, whereas the leave side was using less sad language. Interestingly, in all of this, you see future versus past language. Just the nature of language is that you talk about things in the present or past tense more than in the future in most contexts. So this is saying that everyone used the past more than the future, but the leave side's use of the past was smaller relative to the remain sides. The remain side used more tentative language. There was a lot more very direct assertion without resort to hand-wringing and uncertainty among the leave side. And we also see that there is a much more use of power language among the leave side than among the remain side. So when you put all this together, the only area where the remain side seemed to outdo the leave side, except for the sad language, was in quantitative language. A lot of numbers from economists about the potential consequences economically. The leave side's only number seemed to be the one about the 350 million per week. So if you sum that up, you can find out that essentially the leave campaign was arguing a much more direct and positive. There was much more direct and positive language in that dialogue than among the remain side. So someone could have used that to analyze that and tell the remain side to change its argumentation. Of course, this wasn't a concerted campaign. This all comes from social media. And if we were to track the positive versus negative emotion, for example, you can see that pretty much across the board, with only one or two areas where the smooth curve dips to intersect, the leave side was using more positive language across the entire time series. And you can also see that they were more tentative across the entire time series among the remain than among the leave. Okay, let me show you another application of data science to this, moving right along. Topic models. Topic models were developed in computer science about 10, 15 years ago. They consider that language is generated through a process known as latent Dirichlet allocation. You may be familiar, you may not, if you, it has applications far outside of language, but it's revolutionized at a certain time anyway. It's considered a little bit old school now, but it's a very useful technique for using an unsupervised method to determine buckets of words that are attached to topics, which allow you to sift through and determine what sort of topics were discussed in a set of text. All you need to determine, tell the computer, is how many topics to look for. And there are ways to basically fit that as well. So it's a type of unsupervised machine learning that detects topics. We did this for concatenated data for leave and remain accounts that we had identified from the classifier. We included about 700,000 accounts for this, and we used a variation of this latent Dirichlet allocation called a structural topic model. It allows us to introduce categorical covariates to determine the effect of a covariate on the topic prevalence for one of the values of that categorical covariate. Our categorical covariate, not surprisingly here, was whether you were pro-leave versus pro-remain. We can see the influence of the effect of being a pro-remain versus pro-leave on the prevalence of the topics. This plot summarizes both the labels that we attach to the topics and the effect of being in the remain side. The remain side was least likely relative to the leave side to use a topic we identified as Donald Trump, Islam, or the leave debate. Taking control was a very leave-oriented topic. Down on the other side, we see that talking about mobilizing votes to try to defeat the referendum, that was a remain topic. Anger against the leave campaign was a remain topic. And talking about some of the economic topics that you see there, the Scotland and Northern Ireland, that was a Remain topic. So was Brexit and the economy, Brexit and the market, Brexit and the EEA, for example. And we can produce word clouds for each topic just to see, for example, there's one that was clearly about Joe Cox and Islamophobia. We can look at some of the most prominent tags from those sets. There is also, for example, if you're wondering how we attach these labels, if you just look at the word cloud, for example, for Scotland and Northern Ireland, you can see that the words Ireland, Scotland, Irish, Scottish, England, they dominate these word clouds, and that's the basis on which we assign the labels. And the same thing for some of the economic topics. The full set of topics by side is here. One of the topics that clearly emerged, for example, is Brexit the movie. If you look on YouTube, you can find this wonderful piece of cinematography called Brexit the movie. And you can also see that there are a lot of economic topics. There's a topic, Obama in London was a predominantly Remain topic. We can, because this topic model allows for us to look at correlations of topics, we can actually do a network plot and label the nodes by whether they're pro-leave or pro-Remain and see which ones are connected. I realize you can't really see this, and I can't seem to pinch and zoom, but I'm sure these slides will be available somewhere. You can see which topics were connected to other topics in terms of co-mentions and the correlations that were estimated by this particular model. So, in summary, we are able to use text mining in a social scientific way in this application to predict the side of the user, adding additional information from the text that wasn't originally part of the text as metadata. We're able to determine, in a descriptive sense, what the most common terms and hashtags and users were among a particular side given that classification. We were able to use followership networks, which exploited the metadata from social media in order to estimate affinity towards a side in the form of this, what we call ideological side. We were able to use sentiment analysis to measure dictionaries. There are supervised models that I've worked on and actually developed and have published on for using supervised methods to measure sentiment. Here I just used a simple dictionary method. We can analyze the topics and we can map the network connections between those topics. How did I do this? Raul mentioned that I operate more in the R world. That's true. We have a very large software package that this was a screenshot from yesterday. It's been downloaded 136,000 times. It's getting about 8,000 downloads a month. It's published on the comprehensive R archive network. It's called Quantitative. Stands for Quantitative Analysis of Textual Data. And you can see the commit activity from the GitHub repo. We're pretty active on this. I haven't been active this week because I've been marking, but I can't wait till that's done. I'll get back to this. It's part of an ecosystem of packages that involve ways for doing part-of-speech tagging and natural language process pipelines for converting documents, dealing with encoding issues, and converting documents is actually the hardest problem in NLP, getting your documents in the computer. There is a package for doing, there's an entire package for stop words, and the back end of this, there's a lot of C++ in this for efficiency, and there's some Python stuff that integrates for back-end things, and we're about to add something that depends on Java and Tika, which is Apache's library from Java to basically do more document conversion, because as I said, that is probably the hardest thing in NLP. If you're interested in this, you are welcome to get in touch with me or talk to me during the break, or look at the website and see, if you're interested, we have contributors, a lot of contributors on this project, and it's all open source. Thank you very much.